Welcome everyone to my channel Space Remote Sensing and GIS, and today I am going to show you a very interesting way of doing the flood analysis over the Sentinel-1 SAR images. Okay, so as you know, like previously also I showed some technique to analyze the flood data. Okay, using both you can do like either you can go with ArcGIS Pro or you can go and do it over the Sentinel SNAP software. Okay, but I will make a very interesting way, like if you combine these two, okay, so then you can very fast to do analysis over the flood. Okay, for example, I am going to show you a way of very recent flood analysis, okay, which we actually did. So that is over the Vietnam. There is a cyclone came. Okay, so there the very much area is actually affected. Okay, so I will show you first the image so that you can understand. So this is the image. If you see, this is the before flood image and this is the after flood image. If you see very clearly, it is visible. Okay, so very much area which is affected by the flood. But the first objectives, you know what, that is how you are going to prepare this image. When you are downloading the Sentinel image, if you go with the ArcGIS Pro step by steps which you seen there, okay, so that is it is actually a quite big size of the image if you see, and it is taking so much time. If you go directly pre-processing and then make the data ready and then you do the analysis, okay, so then it will take more time. So if you want to make the work more faster, okay, so then you can finish it within 1 or 2 hours. Okay, so how we are going to do that? So if you combine these two different software analysis, okay, so then it will be very fast. So I will just going to show you the process. Okay, so this is not a raw image. So if you see, I have the raw image with me which I'm going to show you first. So if you see here, I already downloaded this raw image over here. Okay, and I also have, this is the after image and this is the before image. Okay, so this two image which I already have with me. Now if I open the SNAP software, okay, so first thing what you will do, you know, like you just prepared a model. So if you prepare this model, okay, so next time, every time you need not to spend your time to do the pre-processing over your data sets. Okay, so for this, if you see, I already prepared a model which I'm just trying to open you. So if for that you need to go to this tool. Okay, if you are already prepared this model, but first time if you are going to do, then just go to the tool and open the graph builder. Okay, so here if you see, previously I just showed you how you are actually going to create a graph, okay, step by step process, but here already the graph I have, so that I am just going to upload. Okay, so if you see, if I go in a file and I will click on this load graph. So I already prepared this model which is called flood model. Okay, so if I this is not exactly the flood model, this is basically to creating your data ready. Okay, to make your data ready means for SAR image, the basics pre-processing you need to do if you are using the Sentinel image. Okay, it is not directly pre-processed image. Suppose if you are using the ISRO ES4 data, it's a pre-processed data. If you are using the ALOS data, so that is a pre-processed data, so no need to do the pre-processing. But for Sentinel, you minimum need to do this process. Okay, like if you see, if I go to the first steps is a calibration, second step is the speckle filter, then is the terrain correction, and finally you can convert it to linear 2dB. That's all. This is the three process you should have to do. Okay, so now before you upload, what you have to do, I am just telling you, first you have to add the data. So whatever are the data sets I have, suppose before image I have, so this compress image. Okay, so no need to extract, no need to compress image, you just open, it will be added. Then come to the toolbox, click the graph builder. Okay, open the file, click the load graph, click flood and click open. So now your image is open. So you see automatically it was uploaded. Okay, if you are opening over it here, then the data will be automatically come here. Okay, so and somebody want to add this, so you can check my previous video how to create a graph builder, that also I explained. But for your reference, all the tools are here, Radiometric. Suppose you want to calibrate, so just drag this tool and put it over here. Like that you can prepare the toolbox also. Okay, so that is the way you can very nicely you can generate a tool. Okay, and you just need to click, or you can right click over this. Okay, you see here, Yeah, you can click on add. Okay, so here radar. Okay, suppose whatever the processing you want to do, okay, you just check radiometry calibration. So see, this is calibration 2K. So as of now I don't want to this, so I just delete it. Okay, so now this is the steps, this is the process of how you can create the graph. Okay, so this is calibration. If you see here also, all it will going to show you the calibration. Okay, so what are the things you want to do, I applied over the VH because VH is giving the best results for my analysis, so I'm just going to take the VH. Okay, so if you want to apply the both, that also you can take. Okay, and linear to db, and finally read wherever you want to save your data, just right click. Okay, and here save in that folder. I already saved these data sets. Okay, so it is taking quite amount of time to do this analysis, so that's why this is a one-time work, like it will save your at least 1 or 2 hours, because if you just creating this and or you can step by step you are processing this, it will take time. Even in for the ArcGIS Pro, if you go the step-by-step process to pre-process this sentinel image, so that will take quite amount of time. But this process, if you create a boulder and this, if you run this, okay, if I run this, okay, I am not running because I already prepared this as I showed you. Okay, so then it will take hardly 10 minutes to finish this total data will be ready. Okay, so this is a significant amount of time you will save to pre-process your data, which is the sentinel. Now your data is ready. If you see this, my data is ready. Okay, so I have my before image and after image. Okay, so this is the two image I already estimate. Okay, so now the thing is how we can calculate, okay, from this two image, the easiest way to identifying this particular changes. Okay, so this is the mainly our focus is this black area where there is a flood. Okay, so we will only want to target that much, we do not target any other. So the best way to doing this analysis, which I found in ArcGIS Pro, it is a very good, which we usually thought that is basically used for multispectral tool, but it is quite nicely work over the SAR images also. So the technique just I am going to explain you. So if you go to the imagery tab, okay, so here you have options for called change detection. Okay, so click on the change detection tool. Okay, so it will be open over here. So now the from raster, suppose I am giving my after image and the to raster is my before image. Okay, suppose I am just doing that. Now the next step is, if you go to the next, okay, so if you see here, then it will ask you the difference. So usually in multispectral, what we do, we just calculate the band index difference. Okay, and then usually we select the MNDWI or NWI. Okay, normalized water indexes, that is usually do applied over the both before and after image, and then we are going to subtract. But in this case, we just going to subtract the single band difference. Okay, so because we are using the single band VH for the both, and within the VH band before and after, so what are the changes, that area I want to target, that area I want to highlight. Okay, which is basically my flood area. Okay, so that is what that is my target. So if I select that, okay, and then just simply click on the next. Okay, so if you just switch off this, okay, and calculate this. Okay, so let's see the results. Okay, so see here. Okay, see this here. So whatever this red area now, this is actually your flood area. So if you want to verify, just switch off this and see the permanent water body is not included. You see here, this is your permanent water body, but that is not included in your this. Okay, but very nicely whatever the change areas na, so that will highlight very nicely. That is the main focus, that is your main focus over here. Okay, so I just going to show you the steps, the next steps what we are actually did in a next way, without running this all the process, just to show you so that you can understand. See, first thing what you have to do, like if you see this sentinel image now, those areas are not exactly matched, because the scenes are not exactly matched before and after. You see there, this is your before image is little bit down, is not coming, because if you see the sentinel, you will not found a similar path. Okay, in SLC maybe you will found, okay, because SLC is designed for getting a same path, but for before and after image maybe you will not get exactly the same locations. You can get, but you have to check the timing, okay, downloading timing. So if you check the downloading timing is close, then the path will be exactly matched, otherwise it will be a little bit shift. Okay, always you found whenever you are downloading the sentinel image. But anyway, this is what I am going to did it here. I will show you to make this in a common, okay, common place. What I did, I created a shape file. Okay, I just created a shape file. As you've seen here, this is the shape file which I created, and it is very nicely you can create. Like if you go to the edit, okay, so you can go click on the create, and since this is the study area which I already created. Okay, so first time when you are creating, you can create it by yourself also. Okay, like you can go to the analytics tab, and you can go here and folder, this is the folder. You can right click new and you can create a shapefile. So that is I already created. You see here under this I have created already the shapefile, study area shapefiles. Okay, so that is what I created here, and that is my study area. And then using this create study area, and then I just draw this common part, okay, which is my target of focus. So two reasons you are going to do this thing. One, because the sentinel size is very big, that we should not consider, okay, because it's taking so much time to pre-process, so make it area small. Okay, and the second is to when this two area, it should common it is actually the before and after image should be match. Okay, it should not be some extra, some is less, so maybe it will going to affect in your model. So always better is your study area size should be same for what you are targeting. So that is the reason I just create this study area. And then how I'm going to clip it is very nicely, you can clip it very easily. Okay, so suppose this is the before image I'm selecting. Now I'm come to the imagery. Okay, so raster function you can come, and here you can type that's called clip, CLIP clip. Okay, so this is basically the raster clip. Okay, so now you can give here your image, the before image suppose, and the clipping image you can give it here as your study area, suppose my study area. Okay, so that I can clip it here and create a new layer. So once I click a new layer, so you see here the before image is clipped out. The same process I just need to do over my after image also. Now you see the before and after, now we have the similar area, there is no change in this. Now the process is same which I explain you, just go to the change direction. Okay, so here you can give your after image, clip after image, and you can give your before after image. Okay, go to the next. Okay, and here single band difference, click on the next, and this is the preview. If you see here, I am not going to do it again, so this is the preview, we will get it over here. Okay, so this is basically the preview map, usually we call it as a preview map. Okay, now this is my preview map which I already created over here. Okay, now the next steps which we are going to do, that is basically I am going to extract this. Okay, so nothing, just it is, if you go in a change direction and if you make this as a steps as a finished, okay, so just like this which I already make, if you make this process as a finished, okay, so you will get a change analysis map. How the change analysis map is looking like, if you see, this is the change analysis map. So whatever your change area, that will be coming as a highlight. Okay, it's a bright. So if I open this, see, this is the change map which I created from this. So this is basically previous image, like clip after, from, and the before. Okay, so you can go to the next. Okay, so here you have the single band difference of both of each. Okay, then go to the next. Okay, and you see here just this is my calculate, so it will create the change map, and then go to the next, and this is the change direction map. Okay, so which is created. Okay, this is change direction map. So now if I just that is what I created over here. I will just going to switch off this change map so that you can understand this. Okay, so sorry, this is the preview mask, I'm just switching off, and this is my output. This, what is the output you are saying, that I already created over here. This is my change map. Okay, now how we will going to extract this. Okay, so for extracting, the same process which I showed you many times of different my targeting, but where the feature targeting whatever we are doing. So there is a different way, but it is the simplest way. So the first is our target is to classify this image. So I will go to the analysis tab, okay, go to the toolbox, and here we have the spatial analysis tool. So if I click on the spatial analysis tool, and we have the options called multivariate. So I just go to the multivariate, and here you just remember what I need to go do is, that is basically I have to give the input of the change direction. So one thing, like if I give the change direction map from here now, so this is the change direction map which I am going to classify. So I will click it here. So what, this is the image which you will going to input. Sometime if you see it is not taking output, some error it will show. So always better is you can select this, go to the geodabase and see where is the location of this. Usually it is locations is found wherever you are creating the geodabase now. So that geodabase it will directly show you. Okay, so that will be very careful. Okay, so this is, you see under the geodabase, that folder, this change direction image will going to show you. So you have to select like that. Okay, like I am telling you, like suppose I have my geodabase here. Okay, so under the database, wherever I have my data, so there I have one geodabase. So you in the geodabase, I have this data sets. Okay, so see here, this is a change direction. So whatever I am running by default, so it will come into particular geodabase. So you have to select that. Okay, then number of classes I given as a 4 or not 45, 4. Okay, so you just go and run this class. So once you run this class, so you will get this image. Okay, so this image is basically, if you know, that is basically, if you see here, whatever the change value, so your change value is a high value. So your high value is a 4. 4 means that is the area which is changed, means this due to the influence of the flood. Okay, these areas are actually changed. Okay, now the next step is how I am going to target only this red area. So for that I need to do the technique that is called reclassification technique. So if I come to the reclasses, okay, I click on the reclassify. Okay, select that image, the change image. Okay, so now I can change my all value in 1 and 4. So I am just clicking it here. So 4 is my high value, so that is my target value. So I just kept it as it is. I will simply run. So once I will run, I will get this as output. Okay, so this is my output. So if you see wherever the green areas are showing, so that is basically the change of the flood. So few noises are there. These are the little bit of noises is there. So we can remove the noises also in the end. Okay, but this is the major areas. If you see very nicely, you can demarcate from the SAR images. Now the next step is you need to go to the favorite and type raster to polygon. Okay, so click on this, give input of this change image. Okay, so this is my change image. I will just give it as an input, and I will select the simplify polygon and simply click on run. So once I will click on the run, I will get this raster as a single class. Okay, so if you see this is the single class raster which we'll get. Like means it is actually extracting all my values. Okay, if you see this is combining all my values. So but how will understand which one is my flood area? So just right click, go to the attribute. So whatever the value which will be 4, considering 4, so that will be your grid code. Okay, so grid code 4 is your flood area. So simply click on the select attributes. Okay, and then select grid code and click on apply. So see all the values are selected which is falling as a 4. Now you need to right click, okay, go to the data, and or you can do it because it is temporarily I'm doing. So simply click on the make layer as a selected feature. So once you click the make layer as a feature, so all the 4 will be going to select. So I will just remove the selection. I already extracting that I show you. So this is the only, you see, only this is actually having the value 4. But this is sometime you see some extra points are also there, like few noises which I told you. Okay, so the best way is you can manually select. If you want, you can manually select this major area, just taking this selection tool. Okay, selection tool you can take as a selection tool, and you can just manually select like this. This is your major area which having contain some major things. So you see this will going to select like this. Okay, so it may fill this areas are because small dot points or noise are there because it is a SAR image. So that you can remove like this. Okay, so if I remove it, this is my final map which I presented. You see here, this is my final map. Okay, you see exactly it is matched with the flooded area. So if you see this white area, it is matching, but if you open your after image and if you try to match this flood area, okay, so see it will match. Sorry, this is change image, I need to switch off. Yeah, this is the black. Okay, so this is your flooded, and if I switch on with this, see all the permanent water bodies now that will not include in your change in which is created. So this is only include the area which is the newly freshly water is actually affected. Okay, so the increased water, or you can say the flood area, okay, so that is demarcated very nicely over here. Okay, so this is all about this particular analysis. So if you like this video, so and I think you can use it for your analysis who are actually working in disaster monitoring. So last week I just focused over the volcanic eruption. So now this week, because as you've seen, there is many places there is a flood this year, basically of the climate change. There is so the monitoring is very important for immediate decision and for the life support if you want to send. Okay, so the monitoring is very important. So this type of mapping you can do and generate within the 3 to 4 hours. Not I am telling more than 3 to 4 hours is so much, but you can generate it in 1 to 2 hours if your model is ready. Okay, and using these techniques, just half an hour or 45 minutes you can generate it. That is the power of between you can say the mixing of these two software like SNAP and the ArcGIS Pro. So if you like my video, please share it to others, and please give your comments on this particular video. Okay, thank you very much. Please subscribe my channel and give your comments also.